Hi everyone, I'm Ali Reza, and in this video I'm gonna show you how you can create an AI assistant agent using N8N. We're gonna cover this workflow this time on a local version of N8N. In my previous videos I covered a lot of concept using cloud version of N8N, but in this particular video we are gonna see how it's gonna work when we are using the local version. So this video is going to be a step-by-step video. So I'm going to walk you through all the steps are needed for you to get this done. There is no coding experience is required for this video. So you can easily configure everything here and should be able to get the same result as I do. So I'm going to tell you a little bit about the topics I'm going to cover in this video. As I said, N8N local installation will be covered. We're going to use Docker a container for this concept. We're going to use Postgres database to cover for the knowledge base, also for the chat memory. I'm going to also show you a little bit about the RAG, retrieval augmented generation concept. I'm going to walk you through the concept, also explain a little bit about the vectorization, embedding, and see how we can also understand how these capabilities can make our agent smarter. So it's not all about that. We're also gonna expand the agents to get data from outside. For example, connect to the search engine and get information from the Google. And whenever the data is not, possible to find from the retrieval process from our knowledge base. I'm gonna also look into how we can actually process multiple files in the vectorization process. What if instead of one actually PDF file you have two? How you're going to deal with that and how AI agent is going to react to that. Then we're going to also connect to the Google Sheet, we're going to connect to the Google Calendar, we're going to connect to the Gmail and see how we can expand the capabilities of the AI agent. This tutorial is also a little bit different from the other tutorials I had because I didn't plan for everything up front. So sometimes maybe I face with some issues and things that it's unexpected, but we're gonna see how we can actually fix everything. Also, it's also give you really a good indication how these things works in real world in terms of the development. I would suggest that in the first time, maybe you just watch the video just to make sure you understand the whole concept. You understand how I'm doing different things and why I'm doing that. And in the second time, probably you just follow the video and pause and just do in your side and then continue the video just to make sure that you follow everything. I also put all of the files and documents I mentioned inside the video in the school community. You can go to the school community and get all of the templates. So in case you want to just get the template and with a little bit of effort you just get it up and running, you can also do that so you don't have to follow the whole steps. So let's just dive into the actual tutorial and see how it goes. So first thing first, we need to install Docker Desktop. Based on your OS, you need to install either on your Mac or on your Windows machine or any other OS. So you need to go to docker.com, and if you click on the Get Started, it will direct you to this page where you can download the Docker Desktop. So I already downloaded the Docker Desktop and installed it on my Windows machine. So once the installation is finished, you can see the Docker Desktop like this. And here we are going to run some of the containers that we need. The interesting thing is for running the N8N on your local machine, there are lots of different ways, and some of them might need a little bit of more knowledge about the programming and setting up the kind of configurations in a way that most of the time developers are aware about that. But I can imagine many of you might not be a developer or might not have that experience. So Docker is the best way because it's very easy. Everything is ready. You just run it on your local machine without any hassle. So in order to do that, we go back to the website of N8N.io, and from there you can click on the GitHub. This is the repository from the N8N for the community version. So you can scroll down, and from there you can find deployment code for the Docker. So I just copy the code here and I come back to the Docker desktop. Here in the Docker desktop you can find the terminal here. So you click on the terminal, and here you just paste your code and just enter. So it takes less than a minute based on your internet connection to get the container up and running. So I'm gonna make a coffee quickly and come back. So the installation is done. Once it's done, you will get the address on your local host, and usually it's on the port 5678. So if I click on that, I will get to the first page of N8N. This page, if you see this page, means that you have done fantastic job to install the Docker container successfully. So what you need to do here, you need to fill your information. So for that, I just paste my email address just to make it faster. My first name, last name, and a strong password. And if I click on the next, it will come up with another questionnaire about your company, your role, a little bit more information. And here it's a page that it asks you if you want to receive a free activation key for some of the advanced features, which is included in the license that you can get it forever. So if you want, then you just fill your information here and you get the license key for that. So I can actually do that because I haven't used this email before. So I think I should be able to get the email later. Okay. This is the page you have for N8N when you start the N8N for the first time. As you can see, there are some informations on the page. I'm going to walk you quickly over these features and things on the screen. As you can see on the top, on the left, right, there's a button to create a workflow. So with this button, we can immediately start creating our workflows. Also here, it shows you some interesting information about the previous executions. If you already, for example, when you set up the workflow and you activate the workflow, then after a couple of hours or days, depends how your schedule is defined, you will see the executions of your workflows. And if something goes wrong, also you can see the failures here. So it's really good to get some insight for your workflows that you are running. So on this side also you see the credentials and executions. I think it's another page also to show you about the activated workflows and when they are started, the runtime, other things. And on the left there are some menus. For example, this redirects to the templates. If I click on that, it redirects you to the templates page on the N8N where you can find a lot of templates page. And for the variable also, if you want to create some variables to use between different projects, you need to do that. And as you can see, this variables is only available on the enterprise plan. So you cannot use it here. And again, for the insight, it will give you some more insight about the executions. And as you can see, for this feature also, you need to upgrade. Okay, let's go back to the main page. Here is the page that we want to start creating our workflows. And for that, I will click on the create workflow. And here I remember I always liked the dark actually a screen here. I mean, dark theme. Let me see how can I make it dark, because that's what I would like to have. So if I go to the environments, probably, where was that? Yes, it's here, it's on the theme. So I can change it to the dark. I like this one. Okay, hopefully you like also the dark theme. I always make dark whenever I go any applications or any environment. So first thing first, this is the canvas from the N8N. As I said before, I'm trying to make sure that if even it's your first opportunity to start creating any workflows with N8N, I'm going to walk you through this process step by step, and hopefully it makes sense for all of you. So you need to click on this plus, and this is a place that you start creating your workflow. The workflow is about the automation. When we talk about automation, it's about the series of tasks and steps are gonna actually executed one by one. So basically, the question is how these workflows are gonna start. For example, if you are creating a workflow, how this workflow is gonna get triggered or started. And there are different ways to define that. For example, you can create a workflow that you want to start your workflow yourself. So it means that the workflow should be started, executed manually. So each time you want to run that workflow, you have to come to this environment and run your workflow, or even if you connect it to any application outside, you need to trigger the workflow yourself. For that, you can choose the trigger manually. You can also define it to run on a schedule. For example, if you want to create a workflow to post some content on your blog or LinkedIn page, you can define on a schedule trigger, which helps you to run the workflow every 2 hours, every day, every week, or even a couple of times per hour or per day. So these are different options you have. You can also define it on a webhook call. You can also define it in a way that your workflow is get called by another workflow. And that is something that maybe we can actually cover in different videos, because that's a little bit of an advanced topic. Also, another option is to create a kind of a chatbot, then your workflow triggered every time you send a message to your workflow. And I think this is the one that we are going to use, because in this way we can constantly test the workflow and see how it works. So this is the first node. We call it node here. So there are a lot of different nodes here that we connect nodes to each other. And as you can see already, this node has this connector here, which indicates that this connector is going to connect to another node that we can connect to say, okay, what's going to happen after when chat message received. So I click on this one. So as we said, we want to create an agent. So I just look up for agent and I add the AI agent. So when I click on the AI agent, immediately this window is opened. So this is the window showing the configurations of AI agent. But every time you add any node to your canvas, you see this window. And I'm going to tell you a little bit details about this window, because this is really important to understand how this is working, and it helps you to configure different nodes in N8N. So on the left side, you can see the input. This input means that the information is coming to your node from the previous node. For example, in this case, if I close this window, this information coming from the chat message. The chat message is here. If I open the chat here, you can see if you write any message, for example, if I say hi here, so this information is coming to the next node, which is the AI agent. Now, if I open the AI agent, the interesting thing is you can see the incoming information on the left side. So this is quite interesting, because then you already have some materials to work in your next node. In this node, there are some configurations on the middle. These configurations are different from one node to another. So if you open, for example, the Google Sheet, if you open Google Drive node, if you open any other nodes, every node has its own configuration. So these configurations are not the same. But it's important to understand that you can configure this configuration per node here. There is one thing here, it's about the settings. These settings are more or less similar per different nodes, and you can also configure them. In this tutorial today, we're not gonna touch this part because it's not really needed, but in general it's good to know that you have these options also here. There's quite a good documentations are available from N8N, and I really recommend to spend some time to read these documentations. I click on the documentations. The documentations are really written in a really good way for N8N with a lot of examples. And I know most of the time you're interested to go over the one YouTube video and get it quickly done. But of course, if you want to learn how to design and implement these workflows, I highly recommend sometimes to go to the documentation to understand the reasoning behind different things, what are the other options are available, and how these things are working. So this really helps you to not only learn how to run one workflow, also makes you knowledgeable in a way that you are gonna design many other different workflows. So we talked about the left side and the middle side, but the right side is actually interesting. It's about the output of this actual node that we are in now. And at the moment, because this node was not really configured properly, we got an error here. And as you can see, you also get a lot of information in the stack trace here. It's also interesting for people who has a little bit more experience and knowledge in programming, because they might get some insight about what's going on and what went wrong. But in general, this part is about the part that give you the output result of this node. Okay, let's fix the problem to also see what is going to happen here when everything is working. So this is the AI agent. I'm going to hide the chat part. This is the AI agent node. As you can see, there are some connectors here: chat model, memory, and tool. So we want to use the chat model here. So in order to do that, as we said, we want to use Llama. So let's install Ollama and then come back here to fix this issue. Before that, you can also save your workflow until now, just to make sure you're not going to lose your data. There is something else I want to also mention about your local setup, just to make sure that you are aware about that. If we go back to the Docker, here in the Docker, I can close the terminal. As you can see, the N8N container is running. This is also the URL that I already accessed and show you. So if you look in the left side of your screen, you can see the volume. In the volume side, you can see the N8N underline data. So this means that the N8N created a separate volume just to make sure that your data is saved here. What is the use of this? Actually, if you, for whatever reason, you had to remove your image or container here, the good thing is you are not going to lose your N8N data. Okay, let's go to Ollama. Now you need to install Ollama. So Ollama also has a different versions. It is available on Mac OS, Linux, or Windows. I already installed Ollama on my Windows machine. So what you need to do, you need just to run the Ollama here. And after that, if you come back to the terminal, I just had it executed before. So if you run Ollama, you will get this command prompt that it helps you to work with the models on your local machine. You can create them, pull them, push them, list them, and even remove the models from your local machine. But how we are going to add models to our local system? So I'm going to show you in a second. But before that, just to see if already I have some models here, so I can say Ollama list. And as you can see, I already have some models installed on my machine: Llama 3.1, Llama 3.2, Nomic Embed Text. This is the model we are going to use for the embedding later in this tutorial. I have DeepSeek. I have Llama 3.2 with the 1 billion parameters. So if you want to install models, what you need to go to the models here. And as you can see here, there are lots of different models. They are also categorized based on embedding, vision, tools, thinking. There's also some other criteria here if you want to sort it based on the popularity or based on what is the newest model, for example. As you can see, the Mistral 3.2 at the time of recording of this video is the newest one. And if you change it to the popular, you get some of the popular models here. For example, the Llama 4 is already out and a lot of different things. And as you can see a lot of models here. For example, I just don't know one of them. I just want to choose to show you, maybe this one, Gemma. This is the model built by Google DeepMind. And what is interesting here is that each model you also see what kind of model options you have here based on the different parameters of the model, and you can see the size of each model. So how it works, you need to copy the model you want, and as you can see here, you have the command also, what kind of command you need to run. For example, it says if you just run the Gemma, you just run the Ollama run Gemma, and then it will get the Gemma latest. But if you want a different actually version, you need to specify that. For example, we want to have a Gemma with the 2 billion parameters, so I would just copy the command, and here I just say 2b, and then as you can see, it is pulling the model to my local machine. And because it's 1.7 gigabyte, I think it should take less than a minute or something to have the model on your local machine. So this way you can easily download a lot of different models in your local machine and then test the different models and see which model is the most fit to your use case that you're working. So once the model is downloaded in your machine, immediately you can also start working with the model. For example, if I say, what is DevOps? Immediately I can get an answer, and it's quite interesting how it's generating the answer here. Okay, so now we did install the model here. Let's go back to the workflow we had. So as I said, we need to connect the chat model here. When you click on the chat model, you get a lot of options here. As you can see, most of the models that we know these days, they are available here. Mistral, DeepSeek, Google, Gemini, and OpenAI, and a lot more. So let's connect the Ollama here. And when you connect the Ollama, we need to also configure the Ollama here. So let's see, we need to create a new credential. So this usually doesn't work, but let's see. It doesn't work because we need to do it a little bit differently. So let me see. This is the URL we need to use. Okay, so when you're connecting to the Ollama from your local N8N, you need to use this URL to just make sure that you can connect properly to the Ollama, especially when you're running the N8N on your Docker as well. So I can just save it here. Now I can close this window and the Ollama is configured here. Once that's done, I think I should be able to see the models here. Let me see. Yes. Now I can see the models here. This is the same as you saw earlier on the terminal window. So I can actually choose, for example, Llama 3.2 and close the window. I think now my AI agent is properly configured. What I need to do, I need to maybe add simple prompt here, but I don't think so I need to do that. We can, the system message, it's already your helpful assistant. I think that is fine for now. We're going to change it later. So if you open the chat, we just saved here. What is the error here? Let me see. Chat model subnode must be connected and enabled. Okay, the chat model is connected already and it's enabled. Let's just give it a try again to see if the error is gone. Okay, now the error is gone. Nice. How can I help you? So, okay, let me just ask something. Can you give me a script to shut down my PC? Since it's running on a local, it takes a little bit of time, but this also depends on your setup on your side. Okay, it gives me a nice output with a lot of descriptions. So the model is working here, and then you can start working with the model. You can also change the model to different models. As you can see here, we have a lot of different models. As I said, this is not the one that you use for the chat. Actually, you need to use this only for the embedding. So yeah. Okay, now we are in a really good phase of this project. We already created an AI agent. It's connected to the chat model. It's working. So if you are already in this stage, means that you already managed to set up the most important part, the N8N local. Also install the Ollama, which you are able to run the models locally. But one issue with these local models are that they are not connected to outside and they are limited. So in the next couple of minutes, I'm gonna cover the RAG concept and tell you why we need to implement a RAG solution and what is RAG and how it's gonna really help us to move from this simple chatbot to an AI agent which is more powerful and it has more functionality and it can resolve a lot of more complicated issues and answer a lot of difficult questions. So before going to the presentation, I think I missed one step that I want to show you, and that is about the memory of the AI agent. Probably you already noticed that we have a memory connector here, but what we didn't do that just to see if the memory works. So I can say here, my name is Alireza, and just pass it to the model. So it says, hello Alireza, how can I assist you today? So if I ask the model that, do you remember my name? So as you can see, it says this is the beginning of our conversation and I'm a large language model. I don't have any prior knowledge or memory of you. So as you can see, even though in the previous message I passed my name, but the model has no clue about the prior messages at all. So this means that every conversation, every chat you have with your model, it's gonna be the new actually experience for the model. There is no record of the previous conversation. But of course, this is not good because in some of the topics, contexts, we need to make sure that the previous conversations also are actually shared with the model. Then the model can understand what was the beginning of the conversation, what were the topics, and then it will help the model to retrieve the better information for you and come up with a better output. So in order to do that, we can add the memory to our AI agent, and there are different ways to do that. For now, we can use the simple memory. Later, we are going to change that. But with the simple memory, you can also define what is the context window lengths, and this means about how many past interactions model receives as context. So I just keep it at 5, and now I just save it here, and then again I will say, hey, my name is Alireza. So I will pass it to the model, and as you can see, it says hello Alireza. But now, previous time when I asked again, do you remember my name? It didn't give me the right answer because it didn't know. Do you remember my name now? Let's see what happens. Oh, interesting. It still didn't give the the result. And why is that? Because the AI agent is not configured for the system message. So I'm gonna show it to you in a second. But before that, also something interesting here that we need to look at is about the flow that it takes every time you ask the model any question, how AI agent actually take the process of this answering and creating an output. And you can see what's going on here. As you can see here, the AI agent try to actually record on the memory. Also, every question goes to the memory as well. And it's interesting that here it was using the simple memory, but it didn't use it for the reasoning and for the output. This also gives you more information about the tokens. The tokens, it's being used by the model for the prompt, and also the tokens will be used by the model for the completion. In this case that we are using the local model, probably this tokens information is not that useful. But if later you are going to use OpenAI model and other things that you have to pay a little bit of money for that, the tokens are important because then you can see the performance of your model, and the more tokens means that more cost for you. So basically, I noticed also in a lot of different videos outside that most of the time they focus on the fact that to get things done very quickly, and the cost part, it's neglected. Of course, for the chatbots, the tutorial we are working, the cost is not high, especially if you're not generating an image or generating a video, or you're working only for text. This is not going to be really costly, but if you are interested to understand how the cost works for the AI, I think it's important to start learning about the tokens, and that is the part that is interesting. But of course, if you already know a little bit about that and you look at these numbers, if your number is getting bigger and bigger, probably you need to also look into your usage and see how you can optimize your setup to make sure that you are efficient, at least based on the setup and requirement you have. So here also you can also choose between input and output. This also gives you a really good clarity how your model is working. Okay, let's see how we can change this AI agent. And currently the system message we have is only you are helpful assistant. So here we didn't create any instructions for the AI agent to tell AI agent how to take the process of the reasoning. So here we can define the instructions for the AI agent. These instructions is quite important because this will agent how to process your input data, what kind of tools or data sources your AI agent can use, and also the order of the reasoning process is something that you can define here. So I'm gonna expand this just to show you. So I already prepared something. I'm gonna paste it here. So this is a new instruction I created to put here. So now we are moving from a really basic prompt to something a little bit more extensive. What we are going to do here, we're going to define what kind of things we have now. We have Ollama model here, we have simple memory. So what we said is that you have internal model knowledge, you also have a simple memory. Interesting part is the response strategy. With the response strategy, we defined first you can go to the memory, you see what you do have in the memory, and then if the answer is not in the memory, probably you need to go to your internal model and get it from there. And also a little bit about the responding format, what kind of things that we want to consider in the responding format. And we also defined the source of the information the model, the AI agent needs to consider. And if there is something is not clear, the AI agent should ask follow-up questions to make it clear. And we also made sure that if there is something agent doesn't know, just simply says, I don't have a reliable answer for that. So not to come up something randomly. Okay. And these things, as I can tell you, it can be completely different in your case. And you can use ChatGPT or Cloud or Gemini or any other different models to generate your instructions here, but you need to give it a try and test it with your model to see if this prompt is working or not. If it doesn't work, you shouldn't get disappointed. You need to play with that and see what kind of prompt is the suitable prompt for you. So now I'm hoping that this is gonna change the result. Let me see if just save it. Do you remember my name? It's interesting. Now we got an answer. Let's start fresh. You told me your name earlier, Alireza. If you would like to share it again with me now, I'll make sure remember it for our conversation today. Okay, so this is interesting. At least the previous time when I actually shared my name, then I didn't get answer. But you see, by changing the prompt, I already got a different output from the model. This is also indicates how you can change the model AI agent behavior by defining different prompts. Okay, now we covered the basic chatbot, also the simple memory. Let's dive into the next concept. So far, we managed to create a simple chatbot and we connect to the LLM model to generate answers. So in this case, the large language model was Ollama, and as we saw, we were able to have a conversation with the chatbot, gets answers on the questions. Also, we managed to connect the memory to our chatbot. But in a really high level, how this LLM works, as you saw, we provide the input prompt. The prompt means the query that we pass, the questions we ask from the LLM, and the LLM generate answer based on the information is trained on. So this is very simple. But of course, this has also become a kind of a problem here because we are quite limited with this model that we are actually using. So this model probably trained maybe a couple of months ago, 1 year ago. So those informations are limited to until that time. This is one of the limitations. The other limitation is that this model is not connected to any other data sources. So let's go to the next slide. As you can see here, we might have a lot of private databases. If you are looking at this concept for your organization, probably you have a lot of private data sources, internal databases in your organization, which they are not connected to internet, so they are not publicly available. So any large language model, they don't know anything about your data. So basically because of that, so if you ask any question regarding your data sources to the large language model, you don't get any answer, or probably you might get kind of a wrong answer or random answer because the model doesn't know. So basically this is one of the biggest limitations with the large language models, especially when it comes to the specific use cases. If you want to use it in the healthcare industry, financial industry, and many other industries that they have their own data sources and databases. But how we can actually use this LLM to utilize this information and still have the same functionality as we have with the. So basically, one of the way that to do this is to create a RAG solution, retrieval augmented generation. So with the retrieval augmented generation, what we are going to do, we are not gonna actually train the new data. Actually, we are going to do something else. We are going to create a vector database out of our data sources, and what we are going to do, we are going to create a system that each time we are asking any question, the chatbot is going to retrieve some data from the data sources we had and pass it to the large language model, and that way large language model can decide what is the best answer to produce. So basically we are going to find the similar information as we asked from the input, and the large language, we pass it to the large language model, and the large language model is able to generate the best answer out of all actually input information. So this is also really interesting, but again, there's another limitation, is that what if the information is not available in the large language model, it's also not available in the source data. So what that means? It means you ask a question, that question, there is no answer for that in the private data sources you have, also in the large language model. So you might think of, okay, what about the internet? Of course, there are lots of maybe possibilities to have a right answer for the question on the internet. because there are lots of different sources are available on internet, which is not part of the data that you have in your large language model. So by nature, none of the large language models, they can connect to internet. They don't have that possibility to connect to the internet. And that's why we need to find a way how we can connect them to the internet. And when we connect them to the internet, we can provide this possibility for the agent to go to the internet and do the query once they need some information from the internet or any other tools. When you talk about the internet, you shouldn't just think about the searching on the Google. It can be about, for example, connecting to your Google Calendar, Google Sheet, Outlook emails, any other actually things that it's available outside. So any source of information is the case for here that large language model can connect and get the information. And sometimes the agent also can do something for you, like create an event for you or send an email on behalf of you. We talked about this retrieval side. We said when we create a vector database from our source data, then we can retrieve the data and pass it to the large language model. But this process of creating source data is also something we need to consider. And sometimes I think if we don't understand how it works, then it will be difficult also to implement it in our workflows. So I'm going to explain this in this slide. It's about the vectorization process. We already saw the source data in the previous slide. We had a couple of source data. This is the process in a high level how you need to convert your source data to a vector database. So basically we can call it vectorization. Also sometimes also we say we do the embedding, and that's also the same. By embedding, what we say is just we are turning the data we have to the numbers. This is going to be quite maybe complex for many people, so I'm not going to dive into so much detail on that because this is beyond the scope of this tutorial. I don't want to make it also so boring, but definitely for people who are interested to learn more about this, I highly recommend to spend some time, do some research, because there are lots of interesting articles are available out there. Maybe also I create a video later and give some insight about how embedding is, maybe in a little bit of a simple way. But in a nutshell, how we do the vectorization. The vectorization starts from the extraction. So imagine you have a PDF file or text file, any source of data that contains text. You need to extract the text, and based on that, you need to split the text to the simple chunks. So why we are doing the chunking? Because when we do this, when we divide the text to the smaller parts, actually we make it easier later to find similar information. It makes it also efficient because we don't have to go over the whole information every time and pass it to the model. This is not efficient, and especially if you're using the cost-based model like OpenAI and other models, it's going to be quite costly, and that's not really efficient at all. So basically we chunk the data to smaller pieces, and then after that we're gonna convert them to the embedding side. And the embedding process is the process that you actually use the embedding model, and based on the embedding model you convert your data to some numbers. And when you convert the data to some numbers, later it will be easier for the model to find the similar information based on the query you pass to the model. So basically this will be the process that it takes to vectorize your source data. And as soon as you vectorize your data, then we can have a retrieval system in place in which we can retrieve the information from the vector databases. As I mentioned here, when we also able to connect our LLM to different tools, then our large language model is not just the simple chatbot. We can also call it an agent because it can also start acting different things, different actions on behalf of us. And that's why we can also say that we can connect the agent to different tools. That agent can query the tools, or it can connect to the internet and do some search and come back with some more enriched information which can agent use to create a better answer for your question. So I think we covered the presentation here for the RAG and the retrieval system, also how agent can connect to different tools and why we need that. Let's come back to the workflow and start creating the first vector database using Postgres. In order to do that, we need first to install Postgres here, configure it, but don't worry, again, we are going to use Docker, so no extra knowledge is needed. It's going to be a straightforward process, and hopefully you can also follow the instruction and get the same result. Now we want to create a vector database, so we need to create a new workflow for that. So this workflow, maybe we can call it AI assistant agent. So I misspelled. Okay, AI assistant agent. So basically now we can actually create a new workflow. So let's do that. We go to the overview and create a new workflow here. So again, start from scratch. We can put this down. So again, as we did previously, I think this time it might be easier for you to know where we want to go. So we start from the trigger. In this case, I think the manual trigger should be enough because we want to create a vector database once, and every time we want to update, we can come back here and run it manually for now. So what we need to do, we need to connect to the vector database, and in this case, we want to create a Postgres vector store. So we just connect it to that, and here we can use the add documents to vector store because that's the one that we want to connect. And here we need to configure the credentials and connect to the Postgres, which we didn't install yet. So we need to install it first. So, but before that, I would suggest to save this workflow. Okay, it is saved. Now, what you need to do, you need to install vector database. So I open a new terminal here and then copy paste the command here. This command also is the command that you can get from the community. I placed all of the commands, the steps in one document, so it's really easy to follow. You can also see it here, so I think should be fine. So let's see. So we managed to do that. Now it's running, so I think it should be fine. The vector database is also here. So let's go to the workflow and have a look over there. So basically what we need to do, we need to create a new credential. We click on the credential. We need to define localhost, database name, username, and password. So, okay, for the username is admin. The password is 95847, and the database is also vectordb. This should work, but sometimes it might not work because of the local host. It's not able to find the local host. Yeah, I was expecting that. So in order to solve this issue, you need to go back to Docker, and there's one command you can run to get the IP. Actually, this is the IP that you need to use to connect to the vector database. So we go back to the here and just replace it here. Now, nice. The connection test is successfully. Now we are connected to Postgres here. And the table name is something that you can choose. Maybe I would call it knowledge tables. So, and here it says the embedding batch size. It's actually, if you mouse over here, it says the number of documents to embed in single batch. For us, it's fine because we want to cover one document. So what you need to do here is basically we need to add the embedding model as we discussed in the slide earlier. So for the embedding model, we can choose Ollama. And for the embedding, you need to choose the embedding model. In this case is dynamic embed text. So I will choose it here. So that's fine. And this node is about the document loader. So we can use the default data loader here. And we can leave everything as it is except this one, because I'm gonna upload the PDF files which they are in a binary format. So I will select binary here. The rest of the things I think should be fine. I can leave it as it is. So now I have everything here. What I need to do, I need just to give it a try. So I can, just save the workflow. I can execute the workflow. Okay, I didn't still. Oh, okay. I forgot about something completely. And that was the fact that we need to get the files, right? So I said that we need to do it manually, but I forgot that the manual trigger is not enough for us. What we need to do, we need to put the files from the input. So we need to remove this one and we need to add another trigger here. And that was the on-form submission. So the form submission is that it pops up a form which you can actually use it as a submission form. You can design your form here, add some elements, and the form title here is the file upload, for example. And here we can add form elements, and here it's filing, for example. And the element type here is file. It can also support multiple files, that's fine. And then I think we should be fine. The only thing is I need to connect it to the Postgres. So this is still also manual, but the only difference is that we also provide the source file here. So if I execute the workflow now, so I get this file upload on the screen. So I need to connect it to the file. So what I need to do, I need to define some file here. So let me just copy some of the files in my download folder, then we can actually use those files. Okay, I have 3 files here. They're different from each other. So I just want to use it for testing this knowledge source. So first, let's give it a try with the GPT-4o system card. And now I submit the file. I can close this form. As you can see here, what is happening is it is doing the embedding. So you can also, as it's happening, you can also see what's going on here and how this is happening. So this document I provided is not a big document. That's why it might finish very quickly. So it's the GPT-4o system card. I can also open it here in the browser. So this is the document about the GPT-4o. And as you can see, there are lots of information there. And we can start querying about this document. So before that, we need still to set up our workflow. So this workflow is working. Now the vectorization is completed. So with this workflow, we can vectorize different documents and add it to our knowledge source. Before we forget, the name of the table was the knowledge table. So later we need to use the same table when we want to actually the query from our vector store. So let's keep this window open and open another window. Now, as you can see here, now when you open your main N8N portal, you can see the list of workflows here. And now we want to open the AI assistant agent. So this is our agent so far. So what we want to do, we want to add the knowledge, the source here, knowledge base you call it. Then let's add the vector database here. And as you can see, the vector database here is also available. We can connect it here. So this is now the first tool we are connecting to our AI agent, which means that AI agent is going to connect to this tool to retrieve data. So we need to also create a description here. So we can say this is knowledge base. Use this to retrieve information. So we tell the agent about this tool, and agent will use it whenever agent thinks that it needs to come to this knowledge base. So we can also change this to knowledge base, and we need to also change the table name here. So as I said, we choose the same table because we are gonna retrieve data from there, and that's it. So we can go to the next step. The next step here, every time you are dealing with the vectorization, you also need the embedding model, as you can see here. So we need to connect to the embedding model here, and we can connect to the embedding from Ollama. We need to change it to the embedding model. So now I think we should be really good to go. The only thing is, probably we need to reconsider the prompt we had here, because in the current prompt, we didn't mention anything about the knowledge base. So for that, I actually created a prompt. So I'm gonna add the new prompt here. Okay, this is the new prompt. In the new prompt, what I did, I added the knowledge base, and just to make sure that the model understands the knowledge base here. And I also added in the sources the memory, knowledge base, and also the model data. So this is gonna help the AI agent to understand in what order it needs to process the information. I think now we are good to go. So let's just close everything and let's give it a try actually to see how everything is working. I can maybe zoom out a little bit, and let's go back to the document we had. In the document we had, there are lots of information, but let's see what we can actually find from the documentation. Okay, let me just ask these red teamers. What are red teamers? So here you can see the information is provided from the document to Ollama. Now Ollama is trying to generate the answer, but as you can see, it took quite a time to answer. It says the red teamers were a group of external individuals who tested the GPT-4 model. So basically, as you can see, it generates the information from the document. It says the early model checkpoints 10 red teamers, and model checkpoints with early safety mitigation 30 red teamers. So as you can see in the phase 1, 10 red teamers, and for the safety mitigations 30. Perfect. I think it did a great job, at least here, to give us the information. I'm running this whole thing that I'm actually recording for you on a virtual machine, and probably that virtual machine is not as fast as my personal desktop, and that's why, as you can see, it took 49 seconds, the whole thing. Also 2,630 tokens. So this is also the process it took to get to the answer. As you can see, they started with the simple memory, also ended with the simple memory, which means this process is gonna consider the memory in the beginning. Also at the end, it thinks to the memory for the next time. So here also there's a retrieval process, and then after that everything will be passed to the model, and you can see it here. So this is also really great when you wanna trace back what happened to the agent. When there is any kind of troubleshooting is happening, you can also have a look to see what's going on. So this is also interesting to have a kind of transparency on the whole end-to-end process. So this is nice. As you can see here, we had a simple memory here, but you can also use the Postgres to create the memory here. For that, you need to connect to the Postgres and also create a database. I'm not gonna do that now, but if you want, you can do that. So in order to do that, you can, let me just remove this connection. You can connect this and connect to the chat memory. And then you need to create a N8N chat histories here. Oh, let's give it a try to see if it works, because I think it should work actually. So for now, I just deactivate this one, and I just change my mind to test it out. So, okay, in order to test everything here, because we already did something here, probably the best thing is to start clean for the testing. And how we can do that? We can clear the execution here, and we can also reset the chat session here. That's also another interesting feature. And with this feature, we are able to start testing clean. So the previous executions are not really considered, at least here. You can go back and see them here. But I think here there is no data, prior data, so it's not going to impact the chat memory. So I will start with that interesting question that, do you remember my name? I just want to see what happens here. As you can see, AI agent connected to the memory, then Ollama chat model, and the knowledge base. So basically, when we asked this question, probably we didn't expect the AI agent go to the knowledge base, because probably this information has nothing to do with the knowledge base, right? And as you can see, the model is spending quite the time on this node just to query the information. This looks to me quite inefficient here. And yeah, it's interesting. I just asked a really simple question. So after, I think, around 2 minutes, as you can see, we got an error actually by this question. Also something went wrong. Let's just have a look what happened here. So it says invalid input type. If I click on that, so I need to see something, but not yet because it's executing the node. Let me just stop it. See if it shows something to me. Nothing in the logs. Okay, what's here? What I can see here? Node executed, but no items were sent on this branch. Interesting. Actually, things went completely in sideways. Let's just disconnect this one because the only thing we changed was the chat memory, and all of a sudden, agent started acting weirdly. So let's just connect the chat memory again to the previous one and save it and just ask the same question. Okay, my name is not mentioned in this text. Okay, it's going over the text and check if my name is over there. And yeah, I think first of all, it didn't work with the Postgres for some reason, but it seems that this AI agent also, for everything, it goes to the knowledge base. It is correct that we define it in this way, that it should go to the knowledge base and try to retrieve the content. But my expectation was that the agent should be a little bit more smarter to understand if even for my name, it has to go to this knowledge base. So now probably it's a really good time to reach to the next topic, which is connecting to another model. And this time we're going to connect to the OpenAI actually. And for that, let's bring in the new node. So I'm going to remove Ollama chat model here. And then we are going to connect to OpenAI. For the OpenAI here, we need to configure the credentials. For that, you need to connect to OpenAI API platform. And there, when you go to the settings and from the API keys, you can create a new API key. I'm going to create a new API key here for N8N local. So basically, I'm going to remove this API key before publishing this video. So it should be fine, but you have to make sure that you shouldn't expose your API keys. Okay, I'm just copying here, move it this way, and then here you click on the create new credentials in the API key, paste it here, and then when you click on save, it will test the connection, and now it's connected. So everything is fine. So here you need also to choose your models. I think the latest model at the time of this recording is GPT-4o, but if you're watching it later, probably you might have a better models, so you can choose the best model at your time. So this is the model we have, and now we can close this window. Now we will see what will be the difference between the performance between the Ollama and the OpenAI. Let's just clear the execution, reset everything, and ask some questions. So I will start with a really simple question. And as you can see, immediately I got the answer, nice answer. So let me just ask a question. And the other interesting part is that it didn't go to the knowledge base. We didn't change any prompt. We didn't change any configuration on the AI agent. We just changed the model. So let me just ask, do you remember my name? Immediately it says you haven't shared your name with me yet. What's your name? My name is Alireza. Nice to meet you, Alireza. How can I assist? So let me ask you again. Do you remember my name? Okay, nice. It works. So let's I know it was not part of this video, but I'm gonna challenge it again. So let's actually deactivate this one and connect to Postgres again. So I want to connect it to Postgres again, but I just name it chat histories because it will be, I don't want to mess with the different previous tables we had. So now this one is also connected. Let's clear all execution. Ask the same question. Do you remember my name? Okay, nice. And yeah, my name is Alireza. Nice. Now it works. Let's ask, do you remember? Sorry, I ask this question all the time. Okay, and it says also source memory. You see, this is quite interesting here. We haven't seen this, I think, probably in the previous output, but where this is coming from. If you remember in the prompt, we mentioned that always state the source of your answer as one of the followings: memory, knowledge base, model. Okay, let's challenge this AI agent with something different. Now we had GPT-4o system card. Let's ask about this. Is GPT-4o cheaper? Let's see if it goes to the knowledge base. So far, knowledge base has not been used. Yes, it did try to go to the GPT-4o document, and it says GPT-4o is cheaper than its predecessors, and it's faster response, and it's available at a 50% reduced cost in the API. Let's see if we do have something similar there. Okay, let me see. 2 places. Oh, nice. So there were 2 places that mentioned about the fact that GPT-4o is cheaper. And as you can see, the information we had was really accurate from the document we had. Okay, interesting. And as you can see, the source here is also mentioned, so which means that we have a really good actually agent setup now, because it's also cover everything. And it's interesting because the prompt we have here, it's also mentioned the Ollama model. Probably we need to change it to the OpenAI, but anyway, it did work properly even without this mentioned here. Nice. And now we did process one file, but what if we process multiple files? Let's give it a try and see how it works. So we go back to the vectorization here. So we had the flow here, and I want to also show you a couple of different settings. And in the data loader, currently we configured it as just a basic option, basic settings, and we do have several options here, but we want maybe to use one of them. For example, I want to add the metadata, because metadata is a very interesting actually piece of information to add to your data. When you add the metadata, it also gives more knowledge to agent, especially when you have a different type of documents are processing and putting them in one vector database. So the metadata is here, it's a file name, and the value is the one we have here. We can actually drag, we should be able to drag it from here, but at some point I can't. Okay, let me just fix it this differently. What I need to do, I need to execute the workflow again. And this time I want to produce maybe 2 more files. And let's just give it a try. Here we already had a multiple files enabled, so we are able to process different files. In the vector database, I think it's good to change it to the different table. So I will add one S, just knowledge tables. That should be fine. So we do not add it to the previous one. We are using the new table here. I just save it. So if I execute clear the execution and execute the workflow again, now I can choose my file. Here I choose Phoenix project and also .NET microservices architecture from Microsoft. That's the eBook was publicly available. So, and this was also excerpt of the Phoenix project book. So I open both of them here and submit. And now I should be able to get the vector database for both of them. So it's gonna embedding both of them into the vector database. Well, it took 8 minutes and some seconds to finish the process. Of course, these 2 documents were a little bit bigger than usual. Not this one. This one is a short version of a novel, but this one definitely is bigger. I can actually open that one just to see how many pages. Yeah, it's 350 pages. Yeah, that's interesting. So we did vectorize both files, and now we have them in the system. So we can go back and here to test it out. So I changed the table to the knowledge tables, so I can save it here, clear execution, reset everything. We also connected to the OpenAI chat model because it was performing better. It's also faster. You notice already that when you're doing things locally, depends on what is the specification of your local machine. If it's a Mac OS or Windows machine, if you have GPU or not. This is gonna really impact on only the speed, also quality of the AI agent in terms of the performance. It might take a lot of time sometimes when you're using Ollama in your personal computer to process information. So now we got this 2 document. Maybe I can open the other one as well, because then we can have a look as we are testing. So the first one is the .NET microservices. So maybe I can start asking questions about the containerizing monolithic applications. That's one of the interesting topics for the software engineers and architects. Yeah. Can you tell me about So let's see. Immediately it goes to the knowledge base, and let's see if we get something really interesting. So containerizing monolithic application in deploying this, and so it's coming from the knowledge base. Okay, interesting. So it is working, but let's go and find something really specific from this document, something that we can also check from the code base, because then if there's something coding, then we can check. Maybe, I don't know, we can go maybe further in the document, something. Okay, here it says Let me just copy paste here and come back to the agent. Can you give an example of different approach to raise and dispatch events? Let's see, just a question. Can you give me the code example? So we also challenged the memory because we didn't say anything about the previous context. Oh, interesting. Let's see what it says. Although I don't have a specific code snippet available, here's the general approach to implement the default approach to raise and dispatch events. So it says order created events, aggregate routes. But what is the source of this? The source was knowledge base. Let me see. Oh, okay. Order start domain, order context. Let me see, did we have this in the code? I'm just very curious. Maybe I have to look up this one. We do not have this. So basically, let me just look it up now. So we didn't have this in the code. Probably it actually came up something from the model perspective. But in order to make it more specific, let me just ask this question. Can you give me the citation of your previous output? Oh, interesting. The source, practical implementation, details of the domain drive design. Okay, so is there any specific page of the PDF? You can refer to page 236, actually. 236. Let me see. This one, no, maybe it means, oh, okay. 236. You mean this one, okay, interesting. So basically it gave me the citation to the link that on which page I can actually find the link. Let's now, this was really interesting to see how it's different to ask questions using OpenAI versus Ollama. So let me just ask this one. Following the, okay, can you, okay, let me just ask this question. Can you give an example of using let's see application module, but this is more generic than what we have. So because this is coding also, it's just using its model. We can also check it here, but what we can see here, it says it gave all information here. Okay, let me see. Can you give me the exact example of auto fag from the knowledge base? So I just made it a little bit more specific about my question to see if I can have the answer I'm looking. So let me just have a look if we do have such a thing. Okay, I found it. So it's in the another page, 301. It's it says about the artifact. Oh, this is another usage of the artifact and as an IOC container. Okay. Yes, that's correct. So as you can see, it gave me the answer. Previous time also was correct, but it's from the another page because there was another example in the other page. Let's now test another PDF we have, because I don't remember the whole actually concept from this book. Just read it a couple of years ago. So, and of course there are examples in different pages. So this page, this PDF was around 170 pages. It's from the Phoenix project book. That was really famous for years because it was a novel explaining about the DevOps. Now let's see if he knows something about the Phoenix project. Do you have any information about the Phoenix project in the knowledge base? But this book, I'm sure that even the model knows about it, but let's make it specific to see if it can come from the knowledge base. Yes, I found information about the Phoenix project in the knowledge base. This book is the novel, explore the IT, DevOps, and this and that. And it says this, page 112. Okay, nice. Oh, okay, let me ask you a really weird question here. How many pages of this novel we have in the knowledge base? Let's see. I don't know what will be the answer, but I didn't test this before, so let's see if it works or not. Wow, 170 pages. And as you can see, 170 pages. You see, I didn't plan for this, to test it this way. I know that some of the testing here went a little bit sideways, took a little bit longer, but at least it was natural. I think you need also to give this kind of test to your models to see how model react to your questions, how AI agent also react to your prompt, instructions, everything. So let me just ask a question. Can you give me the high-level overview of files you have in the knowledge base? So basically we want to say, what do you have in the knowledge base? So I'm just expecting two, the PDF on the architecting on the container and microservices based application. That's nice. And okay, interesting, contains the Phoenix project as a PDF with total, this was the previous one, okay, no, this one. So the PDF architecting, specifications, and this information is spread across 350 pages in the several sections. Oh, that's interesting. So I assume you have another file in the knowledge base as well, right? Okay, so it didn't consider the Phoenix as an extra, probably because they were really combined as one vector database. But let me just ask this question: what about the Phoenix project? Because we use the metadata here. Oh, in the knowledge base we have another document titled the Phoenix project. This document is a PDF with total 170 pages. Okay, nice. So now we see that even though it didn't give the right answer in the previous questions, but now we got the right answer here. At least it did recognize that there is another file over there. Now we did everything we wanted to test the local models. Now I want to challenge this model for something which I don't know what will be the answer, but that is my question. I'm really interested in several series on Apple TV, and I watched 2 seasons of this series already, and I want to know if the model knows anything about this. Do you know about the Severance series? Okay, see, I was not able to find the specific details from the knowledge base about the Severance. However, I can provide some information from what I know. So this information, the sources model, of course, is not knowledge base because knowledge base didn't have information. So, but now I want to ask extra question. What about the season 2? So because this series has 2 seasons so far, but I know that this model doesn't know about the season 2. So as you can see, it says I was not able to find any specific information about the season 2. And okay, nice. Now we're gonna go to the next step. The next step is to how make sure that the model can actually get information from outside. And for that, what we need to do is to connect the new component, the new node here. So for that, we can connect another tools, and we can search for the SerpAPI. With this component, we can connect to the search engines and start looking for information. You need still to create a credentials for that, and you can click on the documents, and here it helps us to go to the page. For the authentication, we can create a SerpAPI account. So you need to create an account. So I do register now with Google account. It's easier. Then you need to actually verify your email and phone number, and then after that you're able to copy the API. I'm gonna skip those steps. Okay, now I did the verification, everything, and now I can actually copy the private API key. So you can copy the API key from this page and create the credentials. I click on the new credentials, paste the API key, and that's it. It's done. So here you can add some options. For example, you can the Google domain, google.com, for example, the language, English. So everything should be fine. So now we have the search engine API here. We can search it to also the search engine. And what else we need to do? We need to also add the new prompt here. So I'm gonna paste the new prompt here as well. So just to make sure. And this is the last time we are going to change this prompt. So I'm going to make it also big that you can see. So I added also search engine here, also search engine to the last part. So now we configure the search engine here as well. So what we need to do now, we can ask the question. Let me just clear everything. So let me just ask now the question from the beginning. Do you know about the Severance series on Apple TV? Let's see what is the reaction of the AI agent and model. Nice. The Severance is a thriller series on Apple TV. Now it's so much better, and as you can see, the source is a search engine. Do you know when the second season is released? Yeah, this is not accurate because the second season is already released. Let's just ask the question. Severance second season. Okay, interesting. So now it worked, and with a little bit of effort and patience, also changing in the context of the question. So now we connected the search engine to this AI assistant, and so far we managed to create a knowledge base out of some PDF documents we had. We created the chat memory with the Postgres. We used the Ollama model, also OpenAI chat model. But this is not everything. And then in the next steps, we are gonna connect to the Google Sheets, Google Calendar, and maybe we can also connect to the Gmail and see if we can enrich the capabilities of this AI agent. As you can see so far, it has been with a lot of successes, failures, maybe the errors, different things that we have to fix. So far we didn't write any lines of code, and which means that you just configure everything on the GUI, but at some point you see that you need also to do a lot of tests back and forth to see if the quality is what you expect or not. Okay, let's go to the next step. So in this stage, we want to connect to the Google Sheet. So before that, let me just make this a little bit sorted. As you know, the way you can actually sort out your workflow components is to select everything. And if I right click here, I can see the tidy up selection. You can also do it by shortcut. So this looks more nicer. So this is the current workflow we have, and we want to connect to the Google Sheet. For the Google Sheet, what I want to do, I want to connect it to the Google Sheet that I'm used for the video creation. This is my Google Sheet that I'm just adding a lot of ideas for the videos that I want to create, work on that. And this is quite the interesting way for me to keep my ideas and brainstorming. So I can connect it to the agent, so then sometimes I can ask agent to give me the ideas, also tell me what kind of ideas do I have there. So basically what I need to do here is to connect to the new tool. So you can connect to Google Sheet. If we click on the Google Sheet, then you get this node here. Then we need to start from the credentials. Credentials is the most annoying part maybe in N8N workflow configurations or any other workflows, because you have to connect to so many APIs and you have to configure this credential every time you create a new node or component. So here we need to create a new credentials, and we have to fill the client ID, client secret, and a lot of other steps we need to do. So for that, you can go to the documentations by clicking on this link. As always, it gives you a lot of good information about how you can proceed with the authentication and credentials. But I'm going to walk you through that because I have to also set it up and I didn't do it before, and that's why we do it together. So for the Google Sheet, we need to enable two services. One service is the Google Sheet, the another service is the Google Drive. So let's actually go there and first enable both of them. So you have to go to this part and maybe ask for the Sheet and Google Sheet API. So we just enable it here. And now Google Drive. We just enable the Google Drive as well. Okay, now we are finished with those parts. Now we can go to the authentication part. It's the OAuth consent screen. You have to go here, and here you need to start creating the authentication client. So I click on that. Application type here is web application. I can keep it as web client 1, or maybe I can call it N8N local client. So this part authorized redirect URLs. You can go back here. You can see it from here. You can copy and paste it here. Great. And it says it might take 5 minutes to a few hours for settings to take effect, but usually it works immediately, I would say. So we have the client ID here. We just copy it here and put it here. Okay. So now what we need to do, we need also to create a secret here. We go inside the client ID and we have a client secret also here. We just copy the client secret. So we did everything here, and we need just to sign in with Google just to also do the consent process. But before that, we need to save here, of course. Let's save it. Now it's saved. You have to go to the audience and just add the test user. AI studio at gmail.com. Okay. Now we just save it here. I think everything is fine. Now what we need to do, we need to go back to the N8N, and here we need to sign in. You sign in with the same account as you actually define the authentication. Here it asks you for the verification. I click on the continue. That's the most important part that you need to give consent, because without that you cannot actually create a file or access to the files. And that's it. Then we just continue and connection successful, and just we close it here. So now we should be able to connect to the Google Sheet. And if we just click on here, as you can see, we see the name of the Google Sheet as the name we have here. So we just choose the name and also the sheet 1. The sheet number 1 is the one that you have here. So that's why you can also see it over there. It is populated exactly as it is on the sheets. So I think that is fine. So now we have everything here. And if we just maybe execute it here, we should get the all actually rows from the Google Sheet here. Nice. So now we have Google Sheets configured, and maybe I can change it to the ideas, because then, or ideas sheet, then I can test it. So let's give it a try and see how it works. I'm gonna delete everything and let's see. So can you give me the list of my ideas? Nice. As you can see, ideas is already considered here in the flow. So here is the list of your ideas. So how many ideas I got? 10 ideas, LLMs with tools. Teach your AI agent. Let me have a look. Yes, that's the ideas I have. And can you give me first 2 ideas title? Nice. And it's interesting, it uses the memory. So what maybe we can add to this table is the status, because probably you want to also actually sometimes says done, okay, maybe in progress, and some of them maybe in progress, some of them done, and some of them not picked up, or maybe not started, for example, right? So this way we can also make it a little bit more interesting how these things are actually be tracked, because this way we can also track the progress. Can we also use it here? Let's give it a try. can you give me the ideas that are not started yet? So I got 4 ideas. Let's see if this is the same. If I actually sort this. Why I can't sort it actually? If I sort it this way, these are the 4 ideas that I didn't start yet. How to create RAG vs search engine, local with cloud, LLM tools. Oh, nice. This is working really perfectly. As you can see, the source is also, it's considered this as a knowledge base as well. So now we connected to Google Sheet, so we are able to also cover this part. And let's go to the next step. The next step is the Google Calendar. With the Google Calendar, you can also connect to your Google Calendar and see what are the events you have. So for that, let's connect to the new tool, and we can just say Google Calendar. Here, the credentials, again, we have to define. Okay, nice. So for the Google Calendar, we need to do the same. I think we already did that. So let's just copy paste it here. Then we can use the same client and secret that we used. Make sure that you don't copy any extra space, because sometimes that might create a problem with the client secret. Why we are doing this? Because you still need to give a consent that you are gonna give access to your data from the N8N perspective. That's why you cannot just use the credential again so quickly. So if I click on the sign in with Google, it asks me to give consent to N8N local to access these ones. So I give consent. Done. And now here, what we want to do, we want to get the events. So we choose the get many. With the get many, we can get access to the all events. So if I go to the calendar, I have these calendars here. Let's go and see what we have here. Yeah, this is connecting to this calendar, and we have to pass these parameters between two actually dates to make sure that Google Calendar can actually give us the query based on that. So I leave it to the model to do this, and yeah, let's just give it a try and see what's gonna happen. So, and before that, okay, today I already have one meeting scheduled in a couple of minutes, and let's give it a try. So, but before that, model doesn't know about the today date, or does it? Let's ask. What is the okay? What is the day? What is the date today? What day is today? What day is today? Wow, it's 27th of October 2023. So accurate. No, this is not right. It's a different date today, but let's solve it differently here. So how we can do this? And this is an interesting situation, because this day is coming from the model. As you know, the models are actually trained based on the data, and based on that, the information is always older. And that's why we are connecting to all of these tools, to just make sure that the agent is smarter and it's not limited to the data it has. So here, what we want to do is to make sure that the agent also knows the date. And in order to do that, we can just easily connect. It's annoying this. Let me just move this a little bit. As you are adding more stuff to this workflow, sometimes it's getting harder to manage with old nodes. So now we just look for the date, and the date and time tool. It's an interesting tool. it just gives the current date to the agent, as you can see. So the date now is 21st of June. Okay. Now model does know about the date. If I ask the same question now, interesting. This is how we can change everything with the AI agents. It's all about the data and information. So now let me ask question. Can you give me the list of meetings I have today? Nice. This is the meeting I have today from 1 to 3. As you can see, the Google Calendar is being used, and the OpenAI chat model, and the Postgres chat memory. So the search engine and the knowledge base we have is not being used here at all. And as you can see here also, you can see the process. And this is quite interesting how it works. So now we managed also to do that. Let's ask another question, because in the Google Calendar, I had a lot of meetings yesterday. So what meetings I had yesterday? Perfect. So it gave me correctly the 4 meetings I had the day before. So now we managed to connect to the Google Sheet, Google Calendar. Let's see if we can also connect to the Gmail. Currently, I have my Gmail open. So now we can actually process that. So let's see, we can connect to the Gmail, add another tool. Just look up for the Gmail. And here, another credential. So connect to the credential, but this is kind of familiar for you, right? Because you already have done it. So let me just copy paste the client and client secret. And I think this is the last one, at least for this tutorial. Okay. Now I sign in with Google and continue. And now we have to give consent. Even though now I'm just reading the emails, I don't need to give consent to edit or other stuff, but because I'm going to use it in the other videos, so I'm going to do that. But in your case, depends on your situation, you need to decide what kind of permissions you want to give to the workflow. So I just approve, and then everything is done. So now come back to this page. The operation we want to choose is the get many, and we can limit it to 50. That's fine. I think that's fine. It just maybe limit it to maybe 10 email, I think, because we don't want to make it that big. And if you execute a step now, but it says, it says the Gmail API is not enabled yet. Nice. So we go back to the services library. And enable our service here. But Google works very perfectly. As you can see, it didn't take any time. Every time we configure this, enable this, it works very well. So let's see. Immediately worked. It gave me the list of emails with a little bit of a snippet from each email. And this one, maybe we can come back to that later. So let's see. Let's go back here, save everything, clear here, reset here. And this interesting page, I want to tidy up again. Nice, I like it. So, can you give me the list of emails title I have? Nice. I get the email title. Interesting. And as you can see, it gave me the 6 email here. This was the same as what I had here. So is there anything urgent I need to pick up from my emails? So let me just yes, there is an email titled urgent client data breach action required. Okay, it's from Gmail, source eGmail. Nice. So that's also true because this is the one that it has urgent on the title. So this is now getting really interesting because now what we covered is that we added a kind of a bunch of tools and a lot of different parts from the agent workflow. So you have a quite an interesting agentic workflow here in which you process your PDF files. You are able to connect to the outside to query something which you don't have in your knowledge base. You have a chat memory enabled in your system, so your agent understands what's going on in the conversation. You can also connect to your sheets, files outside and get to know about the plans, things you have. You can also have a look to your calendars and see what's going on in your calendar. Also, you can also have a look to your emails and see what kind of emails do you have, what do you need to do. For now, what we did, we are just reading the information, but of course you can easily add another component to send an email or update something on your Google Sheet. That's not a difference. The most important part was the credentials. I think you have done it, also configuring the AI agent that we have covered. But maybe you might have a question that now you did all of these things, how you are going to go to the next step to run this self-hosted kind of workflow, not in your laptop or your desktop computer, maybe somewhere else on the cloud. But of course, you don't want to pay a lot of money for that. And basically, there are lots of options out there. I'm going to show you one of them, and we're going to go through the steps together. And after that, of course, I will cover this in the separate video that what kind of options we might consider. So there is one of the website that is quite interesting is the Render. Render is one of the cloud application platform that you can consider to deploy your apps APIs. So I'm going to walk you through the process, how it's going to work if you want to deploy our N8N over there. So let's get started here so you can connect with your Google account. Okay, what you need to do here, you can choose the web service here. And from here, you can choose an existing image. This existing image can be the same, actually, a Docker image we used. Let me just find that. Actually, Docker image. So this is the Docker image we used. Now we can connect to this Docker image. We can name it just N8N, and we can leave everything to what it is. And here we can choose the free. Actually, this is quite interesting because you can start with the free version and see how it goes. And then after that, if you want, you can choose to the Starter Pro and so on. So it depends to your workflow and how much execution you have, how much capacity you need. You can change your plan. I think you can leave the rest as it is. And now we just deploy the service. It takes a little bit time, so I'm gonna make another coffee, pause the video, and once it's done, we're gonna see the result. So the provisioning is done. Now we also get the URL somewhere. Yes, I think there should be somewhere here. Let me just, yeah, this is the primary URL. It's accessible here. Okay, now this is our actually N8N self-hosted, which is now running on the cloud. So what I need to do, I need to define it again. So it's similar as question we answered in the beginning of this tutorial. And this one I would skip because I already filled it once. So here we go. Now you have everything here, and now you can just import your workflow. The way you can actually import your workflow is you need to download your workflow and upload it. Import it here. So what I'm gonna do, I'm gonna download this workflow. So it's already downloaded. So I'm gonna import it from here. Let's see what's gonna happen. So I think this was the workflow we had. So as you can see, the workflow is already imported inside the N8N we are running on the cloud. But as you noticed, also there are some errors are here, and some of these errors it's just because of the fact that we define the credentials over there, but those credentials are not actually here because we need to define the credentials here. The credentials are not moving between the workflows. That's also something good to know. Also a really good feature from N8N, when you export your workflows, the credentials you're defining here, the client secrets, are not going to be part of the export and import. So basically what you need to do, you still need to define the credentials here again, and I think it's a little bit of an effort to do that. One thing more is that the Ollama here, which was running locally, probably is not possible to do it anymore this way. So my suggestion is to use another embedding model from the other actually model providers, the APIs that you can use here. And apart from that, everything else is the same. So you just keep your settings, you just cover the credentials, and then you have the working workflow here. I think now we covered everything in this video. We created an AI assistant agent. It was an interesting journey to go over the all actually bits and pieces, configurations, sometimes also a little bit of unexpected results, but at the end I think we also get a good understanding about how these things are working together. One extra thing is we also need to know that not all actually AI agents as simple as it is, and I think we already noticed that for some of the scenarios, cases, probably we don't get the answer we are expecting, so we need to spend more time to fine-tune our configurations, settings. So basically it means that this setup is already good enough for many use cases, but not all of them. So hopefully this gives you a lot of good material to start, and this also was a really good step to learn a little bit about the N8N environment, how you can create a new agentic workflow in N8N. So I would suggest if you want to learn more, you can actually go to the community. The link is below this screen. In our community, what we do, not only we provide a lot of more workflows, also I can also give more actually time to different actually community people in case if you have an issue or you need extra support. There are a lot of possibilities there. So don't forget to subscribe this channel to get the new videos, and see you in the next video. Thank you.